Welcome to Complex Linear Relations. Let's take a look at this question over here. 2x plus 2y equals 4. So, whenever we have a more complex question like this, we want y to be by itself, and I'll explain why in just a second. So, we would subtract 2x from both sides. This cancels. 2y equals 4 minus 2x, and we want y to be completely by itself. So we're even going to get rid of that 2. So y equals 4 over 2 minus 2x over 2. This simplifies to 2. This simplifies to 1. So y equals 2 minus x. Okay? That's what it simplifies to. So now we're going to put our points, -2, -1, 0, 1, and 2. Now we want to find the corresponding y values for each of those, so we're going to plug in each of those x's. So let's start with -2. So y equals 2 minus -2, which is 2 plus 2, which is 4. Now let's take a look at -1. So y equals 2 minus -1, which is 2 plus 1, which is 3. Okay, also we should keep writing these points too. 4, 3. Let's take a look at 0. Y equals 2 minus 0, which is 2. So we're going to write 2 here. Let's try 1. Y equals 2 minus 1, which is 1. So we're going to write 1 over here. Now let's take a look at 2. Y equals 2 minus 2, which is 0. So we're going to write 0 over here. Okay, that's the first question. Let's take a look at this question over here. 2x plus 3y equals 6. So we're going to have to solve for y, because we want y to be completely by itself. So we're going to subtract 2x from both sides. This cancels. 3y equals 6 minus 2x. Actually, I think this was supposed to be 3x here. Let me just erase that. 3x. We'll redo this question actually entirely. Okay. Let's erase that. Okay. So we can take away 3x from here and 3x from here. This cancels. So 3y equals 6 minus 3x, and then we want y to be completely by itself. So we're even going to take away this 3. So y equals 6 over 3 minus 3x over 3, which is, this goes 2, this simplifies to 1, 2 minus x. Oh look, it's the exact same question here. Oh wow. So what does that mean? So if we had -2, -1, 0, 1, 2, all the y values would be the exact same because the equation is the same. So all you'll really have to do in a question like this, this is just a coincidence that these two are the same, but I still want to see all the work. So you would do all of this work again. This work over here, you would have to do all of it again. So I'm just going to copy it because I don't feel like doing all that work again. Let's copy it and I'll paste it here. Okay. So, right now you don't have to do all the work because these questions are the same, but say it was y equals 3 minus x, then you'd have to do the whole thing again. Okay, we'll just skip this question for now though because it's the exact same as the first one. Okay, so y plus 4 equals 2x plus 3. We want y to be completely by itself, so we'll take away 4 from both sides. So y equals 2x, this cancels, minus 1. Okay, and next thing that we're going to do is we're going to write our points here, -2, -1, 0, 1, and 2. And now we're going to plug in each of those points. Let's take a look at the first one here, -2. So y equals 2 times -2 minus 1, which is -4 minus 1, which is -5. So we write -5 over here. Now let's look at the next one. Y equals 2 times -1 minus 1, which is -2 minus 1, which is -3. So we write -3 over here. Let's take a look at 0. So this is -1. y equals 2 times 0 minus 1, which is negative 1. Let's take a look at 1. Well, let's write negative 1 here as well. Y equals 2 times 1 minus 1, which is 2 minus 1, which is just 1. So we write 1 here. Let's take a look at 2. Y equals 2 times 2 minus 1, which is 4 minus 1, which is 3. So that's just 3. Okay. And I'll be back with one more question, okay? Okay, so here's another question. So we're going to take away 30x from both sides because we want y to be completely by itself. So 6y equals 7 minus 30x. So, actually, why don't we write, let me change 7 to 60, okay? Just so the whole process is a bit more smoother, okay? 60 minus 30x. So we're going to divide both sides by 6. Divide this by 6. So then y equals 60 over 6 minus 30 over 6. Okay, so then this reduces to 10. This reduces to 5. Oh, I forgot the x over here. Okay, so this equals 10 minus 5 times x. Okay, let's make this a bit more clear over here. So 60 minus 30x, right, and then this becomes 5. Okay. Now, this is our equation. We're going to want to plug in negative 2, negative 1, 0, 1, and 2. So let's start with in different color. Negative 2. So y equals 10 minus 5x equals 10 minus 5 times negative 2, which is 10, plus 10, which is 20. Let's take a look at negative 1. Y equals 10 minus 5 times negative 1, which is 10 plus 5, which is 15. So this is 15. I forgot to put 20 here. So this is 20. This is 15. Let's take a look at 0. Y equals 10 minus 5 times 0, which is just 10. So we can write 10 here. Okay, let's go over here now. I'm losing a bit of space here. Let's take a look at 1. Y equals 10 minus 5 times 1. 5 times 1, which is 5. So we write 5 here. 10 got messed up. Let's take a look at 2. Y equals 10 minus 5 times 2, which is 10 minus 10, which is 0. So this is 0. That's our last table of values. And that's complex linear relations.